Right. So now we have a conversation with William Miller, who's the head of INCOSE's Future of Systems Engineering, also editor-in-chief of the Insight magazine. Bill's a good friend. He has many, many interesting stories from over his long career. In particular, we'll talk about the INCOSE 2035 vision document and how he's ensuring that comes to pass. I know some of you say that you like to read things rather than listen to things or watch videos. So now we've got the PDF summary that you can download in the link below. It's nine pages long. You can get that, and you can look through all of the topics that we talk about in the video. So many cool things and many different ways to get involved. So we'll be seeing you soon. Okay, so I'm here with Bill Miller at the International Workshop for INCOSE 2025. We're here to talk about the future of systems engineering.
Yes.
Bill, what's the future of systems engineering?
The future of systems engineering, well, the overt thing is to realize the system engineering vision 2035. But to realize that vision, we have to fundamentally do a shift in how system engineering is not only perceived, but performed, moving from an emphasis on process to the original roots for system engineering were really about the engineering of systems.
So creating systems that are valuable.
Yes, yes.
Because I find part of the challenge of systems engineering is all these ilities, all these different quality metrics of your system, and trying to coordinate all that is fundamentally.
Yeah. Well, in fact, doing that, so one of the projects that I was chief system engineer on, I was in effect an assistant program manager with complete authority over negotiating requirements with the customer, basically managing technical reviews, integrating all of the ilities, working on a day-to-day basis with the other traditional engineering disciplines, and all the way through the various integration and testing the supplier chains, qualifying them, all the way through integration and test, system test, and sell-off of the system to the customer. And the fun part, well, there were a lot of fun parts, but one of the fun parts was interacting with the other engineering disciplines. And a little joke that in fact, you often don't hear it. So just as an example, every day in the morning, the mechanical engineering manager would come into my office and on my whiteboard draw some F equals MA kind of problem and say, Bill, you're the systems engineer. What's your recommendation? And you rarely hear that from, other engineering disciplines.
Yeah, that's absolutely.
So I basically describing the scope of my work. And by the way, doing the requirements piece was interfacing with people outside the company on deriving requirements, validating requirements, things like that. So.
No, it's really interesting. So where are you seeing the future of systems engineering?
Where am I seeing the future? Yeah. Okay, so it's almost like the movie Back to the Future, back to our roots. Yeah. And in fact, our system engineering handbook, published by Wiley, has a subtitle of System Engineering Lifecycle Processes. And I would like a new handbook, a different handbook that says System Engineering Handbook with the subtitle The Engineering of Systems, and putting engineering back into systems engineering where its original roots. Not that we give up process is there, but following processes does not guarantee successful outcomes.
Yes. And my understanding, there are 4 streams that you work on. There's scientific foundations, there's methodology, there's vision and roadmap.
Yeah, and the application extensions. And the application extensions gets us into additional domains beyond our traditional domains like military, aerospace, medical devices, and automotive. Those are probably the big ones right now. There's probably more that I'm forgetting, but going in. And so the one we're pursuing with active workshops at this workshop is on energy transition. Big issues. And I got a snippet of some of the issues that come up is that one of my son-in-laws works in the wind turbine industry and was assigned to fly to Kodiak Island, Alaska to deal with the troubles there in terms of the grid. So the grid originally started with a water reservoir, hydroelectric power, driven by a reservoir up in the mountains of the island. And when there were issues with additional power, there were very noisy, expensive diesel generators that raised people's electric prices, and again, the environmental noise and also the smoke from that. So the Island Power Authority ended up buying 3 wind turbines and installing them. They did not know that the loads were outside the normal range of what you would experience. They ended up having high induction loads. This is electrical engineering, power engineering kinds of phenomena attributable to the fish canneries on the island and also to a crane, a new electric crane put in the port for Kodiak Island that uses power when it's lifting, but when it's descending, it's generating kinetic energy that's being retrieved and put back into the power grid. So they were having significant control issues for this. And one of the things to finally get stable control was another component they had to add to this system, which was a flywheel.
Wow.
Just fascinating in terms of the complexity of the problem. And truly a complex system because you have people involved, stakeholders involved that have certain needs and wants that needed to be achieved.
Yeah, I hadn't really thought of a crane. It's almost like a regenerative braking on an electric car.
Yeah, exactly. It's the same kind of phenomena. And I mean, but just this is one microgrid.
Yes.
And then other experiences, I was at Newark Airport, New Jersey in August of 2003 when the big power outage hit the Northeast, well, Midwest and Northeast, that started with tree trimming by an electric utility in Ohio.
Sort of cascaded off of
It cascaded. An interesting phenomena. As my wife and I are getting our tickets printed out at the ticket counter, my ticket was printed and then power went out. Our agent had the presence of mind to race to the one computer behind the counter that had an uninterruptible power supply on it, fight people off, and print the second ticket. So we thought, okay, that's nice. We have our tickets, but the power grid down. But wait a minute, this doesn't seem to be a problem because airplanes are still landing and taking off. And we thought, oh, the backup power generators at the airport are in operation. Well, our flight ended up getting delayed by at least 6 hours because nobody had the presence of mind to include the gates to get into the airport area by the fuel trucks and the food trucks. Should be part of that, on the uninterruptible part of the power.
Yes.
So
And
those kind of phenomena.
because I seem to recall when there was the nuclear disaster in Japan after the earthquake.
Oh, yes.
The challenge was the reactor
Yes.
was okay with the shaking, but then the water knocked out the generators that were used to power the cooling
Right.
system.
Yeah. No. It was interesting if in terms of CONOPS for the various scenarios that could occur, it hadn't occurred about the tsunami wave taking out the sensitive equipment that was within the zone of the tsunami wave that caused the reactor to go into meltdown.
So back onto the future of systems engineering. If someone wants to learn more or want to get involved, what should they do?
Okay. Turn on your favorite search engine and put in System Engineering Vision 2035. It'll get you to the INCOSE website where you can either download the PDF visions free of charge or there's a hyperlinked interactive version that you can do. And again, the purpose of future systems engineering, what we're doing, our job is to realize the vision. So we need to be proactive. INCOSE has published their first vision back in 2007 and the second in 2014. And this came out at the end of 2022. And from experience from the past 2 visions, you can't be passive. Things just didn't occur that we would expect it would have occurred. So the idea is to be much more aggressive to nudge the achievement of the vision.
Yes, and I would very much recommend that people do take a look at the PDF.
Yeah, and if you want to engage, we're working the IT structure now, but provide the links on public-facing web pages to engage if you're not a member of INCOSE or a member of INCOSE within the INCOSE space.
Yes, and that PDF or that website is very friendly. It isn't something where you have to be some even have any idea what systems engineering even is.
Correct.
It is something that...
Yeah, by the way, the organization, there's an executive summary. Chapter 1 is the global context for system engineering, including global mega trends in terms of societal things, technologies, et cetera. Now, we missed some things, such as the war in Ukraine and so on. Chapter 2 is the current state of system engineering. Chapter 3 is the future state of system engineering, our vision. And then Chapter 4 is how do we go about realizing the vision, identifying system engineering challenges, recommendations by the vision team for system engineering to take on, and a high-level roadmap with goals, bands of goals for 2025, 2030, and 2035 in various areas of research, competencies, tools and environment, practices, and applications.
Fantastic. Well, thank you so much, Bill.
Okay.
Do you have any parting thoughts?
No, just we want to get you to engage with us.
Yes,
as
exactly.
is the parting thought. It's got to be a truly collaborative effort by the system community, not just INCOSE.
Yes. There are many other organizations out there, be them universities, other professional organizations, and very much Bill's saying you're welcome to come and talk.
Okay, thanks, Joshua. I appreciate it.
Thank you. Thank you, Bill.
Thank you.
Thank you.